The four main organic reactions we discuss in these lessons are combustion, substitution, addition, and condensation. Combustion of hydrocarbons, or of CHO compounds, produces carbon dioxide and water. Substitution reactions remove an H and replace it with something else. Addition reactions break one of the bonds in a multiple bond and insert two things. Condensation reactions join two molecules into one and yield water as a byproduct. Esterification is a condensation reaction that occurs specifically between a carboxylic acid and an alcohol. Let's try an example. Let's write the equation for the reaction between butanoic acid and 1-butanol. Butanoic acid is a carboxylic acid that has 4 carbons in a chain, and 1-butanol has 4 carbons with the hydroxyl group hanging off of carbon number 1. Whenever we have esterification, we're going to form water as one product, and then we're going to join together the remaining parts of the molecules to look like that. And what would the name of this molecule be? This is an ester, and the way we name esters is we name the part that is hanging off of the O first, and this is a butyl group. And then we name the rest of the molecule, and it ends in O8, so this is going to be butyl butanoate. In case you're wondering, butyl butanoate is the active substance in the characteristic flavor and odor of pineapple. Let's try another one. Write the equation for the reaction between 3-phenyl 2-propanoic acid and ethanol. That first one looks like a bugger, so let's write the structure for ethanol first, and then let's see if we can break down this 3-phenyl 2-propanoic acid. It says oic acid on it, so it looks to me like we're going to have this structure at the end of the molecule, C double bonded to an O and then attached to the OH. That's called a carboxyl group. And then name would suggest that we have, it says propanoic acid, which says to me that we should have 1, 2, 3 carbons, because prop means 3, and off of carbon number 2, propanoic acid, that should be a double bond, like so. And finally, we need to put a phenyl group onto carbon number 3. That would be this one here on the end, because by definition, the carbon in the carboxyl group is number 1, and hopefully you remember that a phenyl group looks like that. Well, that was the tough part of this one, actually, because now we're simply going to make water, and we're going to join up the remaining parts of the molecules so that we have that. If we were to name this, which I wouldn't require my students to know how to name this, but we would name it like we do all esters, and that is we name the thing hanging off the oxygen first, so that would be an ethyl group, and then we would say 3-phenyl, because we've got a phenyl hanging off of carbon number 3, and then this is going to be called 2-propanoate, which is commonly called in industry ethyl cinnamate, which by the name you could guess that that is the active substance in the characteristic flavor and odor of cinnamon. When in doubt, make water. Many reactions in organic chemistry have water as a product, and if you don't know what to do, it's a good idea to make water. Let's summarize. Condensation reactions between certain classes of molecules yield specific types of products. Here are some condensation reaction patterns we have met in these lessons. Alcohol plus alcohol yields an ether plus water. Carboxylic acid plus amine yields an amide plus water. And here, a carboxylic acid plus an alcohol yields an ester and water.